In this first we use some libraries what are required for our code and macro. In macro we defined port B data and direction register and digital enable register. And the next one we took the sine wave. For generating sine wave we took 32 samples of that wave. Now we are taking 8 different frequency sa re ga ma pa dha ni sa, which are specific to each switch. Now these are the function prototype. In the main function we initialize the DAC initialization, like what is the input of the R2R ladder. In R2R ladder mostly we are taking port B as a input and output is analog input output which will go to buzzer. In switch initialization our input is port E and port F. So in while we read switch we make the read switch a function which read the status of the switch. When we press the switch, that value will go into this key variable. If that value is less than the key, so the frequency will set. We also make one function for set frequency, and our node frequency are the 8 nodes. And after releasing the switch, SysTick will stop, and port data of the that port will be set to 0. Now the DAC initialization. In DAC initialization we enable the direction register, that is we are taking output. So we configure it as a 0 hexadecimal FF, like we are configuring port B from 0 to 7. And for digital enable we configure it as FF. And this is the first we set the clock and give the direction for output, and this is the digital enable for functionality to digitally enable. And then the read switch, in this we are using port E and port F as a input. So we set the registers for direction, digital enable and pull up register, because we are using as a input, so we set the pull up register as a 0F. Why 0F? Because we are using list 4 bit, like PF0, PF1, PF2, PF3. So that's why we make it 0F. And similarly for port E also we did. In read switch we took two variables, unsigned variable, last key and stable key. Last key like previous key what was pressed, and stable key like what new key, like stable key after we use this logic for debouncing. Like if we press the key, then it can detect the multiple input. So we are stabilizing that key press. So for that we are using stable key. Now this is the iteration. This loop will run 5 times, and this is the data of port F, which will go on this variable, and data of port E and F will go this variable. So now if stable key is 0, so that data will go on to this variable. Now if we press the key, this logic will detect the switch, which switch is pressed. So after that it will return to next switch. Return only when status change, like if last key and stable key is not equal to, so this stable key and last key both are equal, and return to stable key, otherwise otherwise return to 8. It means no new press key detected. In above code it's showing that key is pressed, and here like no key is pressed, so it will return to 8. This function we use for the reload our frequency. This is the formula to reload the value in system timer. This is the initialization of system timer. Here is the NVIC status control register. First we disable all the values, and then reload the value whatever we set in above function, and make the current value 0. Systic handler, it will handle the index what we make in lookup table, like it will start from